Let's now take another example of an electrophilic aromatic substitution. This time we try to do sulfonation of benzene. So if we take benzene, and if the benzene ring is treated with sulfur trioxide, SO3, in the presence of sulfuric acid, H2SO4, what happens is actually sulfonation, and benzene sulfonic acid is obtained as the final product. It's SO3H as an electrophile here. So this is benzene sulfonic acid. So clearly, again, if you look at the structure of benzene sulfonic acid, the required electrophile is SO3H, where there is a positive charge on sulfur. So this is what's required, therefore, in this electrophilic aromatic substitution reaction. Now, sulfur trioxide reacts with sulfuric acid. So this is sulfur trioxide. And of course, this is one possible Lewis structure. Of course, there is more than Lewis structure that's possible in this case of sulfur trioxide. So this is sulfur trioxide. This is sulfuric acid. That's the Lewis structure of sulfuric acid. So the first step would probably be protonation of sulfur trioxide using sulfuric acid. So we take one of the lone pairs on this negatively charged oxygen, and then we make a bond between oxygen and hydrogen. Hydrogen-oxygen bond is broken simultaneously. A bond here is formed as a result, and sulfur oxygen double bond is broken at the same time. If this is the case, then what's obtained is this intermediate plus, of course, the hydrogen sulfate as the conjugate base of sulfuric acid. This is actually the required electrophile, SO3H, as we identified early on. This is the electrophile that's required, and that's exactly it. This is how it's formed as a result of this protonation reaction, protonation, if you like, of this alkoxide in sulfur trioxide with sulfuric acid. Now, this electrophile intermediate, or this electrophilic intermediate, is now reacted with benzene. So benzene comes in and it attacks sulfur on this electrophile. So we get something like this as an intermediate. It's a carbocation intermediate again. And of course, there is still a positive charge here on sulfur. Remember, there is a hydrogen here and there is a hydrogen here because we had hydrogens there before. And of course, that carbon now must carry a positive charge because it has lost its electron share. Remember, always this first step, this initial step is always slow. That's when benzene loses aromaticity to give this carbocation intermediate. Now, the hydrogen sulfate can come in, as it does, and takes off that proton. Hydrogen carbon bond is broken and a double bond between these two carbons is formed. Now this gives the final benzene sulfonic acid product, which is this one here. Of course, another resonance form can be drawn on benzene sulfonic acid. This is benzene sulfonic acid, and this is how it's formed mechanistically. The initial step is a reaction between sulfur trioxide with sulfuric acid to give the SO3H electrophilic intermediate that is required in this sulfonation reaction. Now that electrophile is then reacted with benzene to give the final product, which is benzene sulfonic acid. So this is another example of an electrophilic aromatic substitution reaction when benzene reacts again with sulfur trioxide in the presence of sulfuric acid to give benzene sulfonic acid.